Today's project is working on an Evinrude Sportsman 1.5 horsepower. This was my grandfather's motor and it hasn't been run since the late 80s. It has good compression, but I'm going through it top to bottom to make sure everything's fine. In today's video, we're going to restore the magneto and give it a complete service. To gain access, I'll need to remove the lower half side covers. There are 2 screws on each side. They do not have captive screws. And if you were to work on this motor while it's on the transom and you're in the water, you have a very good chance of losing these screws. The recoil starter mechanism needs to be removed. There are 4 screws on the top that hold it to the fuel tank. 2 are pretty visible in the front, but you have to open the fuel door to access the 2 rear screws. When I removed the recoil unit and lifted it off, it appears that this flywheel ratchet base plate was being dragged on by the recoil starter. Looking at the underside of the recoil simplex unit, the rearmost fingers had the most evidence of scraping, but the screws on the other 2 fingers also were scraping. So it's clear this unit was too low that it was touching the flywheel. Using a 7/16 inch socket, remove these 3 bolts holding the ratchet and ratchet base to the flywheel. Using a 13/16 inch socket on an impact wrench, remove the flywheel nut, and it needs to be removed counterclockwise. Here you can see where the hub puller is going to go. We'll use the 3/4 inch bolts and attach the puller. Using a 3-eared puller such as this, and with 1/4 20 screws or bolts, set up the puller with the center rod centered over the crankshaft. Tighten the center post with an end wrench. If the flywheel doesn't come up, tap on the end of that center bolt with a hammer. Tap it 1 time, tighten a little bit, tighten it again, tap it again, tighten it again until it pops free. It will eventually come loose. Remove the 1/4 20 bolts and the puller from the flywheel, and now you can easily lift the flywheel off the crankshaft at this point. As I carefully examined the flywheel, I saw there was a crack in line with the keyway slot that's circled in this picture. With the flywheel removed and flipped over, the hub crack can be clearly seen. An internet search for this flywheel found a used one for sale. When you lift off the flywheel, it reveals all the magneto parts. In our case, there was supposed to be a spring washer that was located between the flywheel and the rotor assembly, which keeps the rotor from floating up and down, but it wasn't there. Using a pliers, grab the woodruff key that was for the flywheel and pull it out to make it easier to remove the rotor assembly. Then just grab the rotor assembly with your fingers and it will slide right up. When the rotor is out of the way, you'll see a second woodruff key. Remove it and save both keys for reassembly later. Here you see the rotor and the 2 woodruff keys. All the components of the magneto can be seen with the flywheel and the rotor removed. You'll see the coil with its armature, you'll see the condenser, and you'll see the point set assembly. Also in the bottom left corner, you can see the spark plug wire was removed from the spark plug. You need to remove these wires for testing. To remove the wires on the breaker point set, you'll have to remove the fuel tank. 4 screws on the underside that hold the tank to brackets. With the fuel tank removed and laying upside down, you can see the 4 locations where these screws held the tank down to the brackets. Inspect the coil for splits in its case. If you do see splits, you will need to replace the coil and the lamination assembly. It's all one piece. To test the coil's secondary winding, which is the high voltage side, Use a volt-ohm meter on the ohms setting and read the resistance between the tip of the spark plug wire and the ground terminal at the coil. Doing this test confirms that the spark plug wire has good continuity, but it doesn't confirm if the insulation is broken down on the spark plug. You can also test the secondary winding by touching to the soldered on point on the coil and the ground location underneath that you saw in the previous picture. A good secondary winding resistance should be in the range of 3K ohms to 7K ohms. That from the spark plug wire to the ground on the coil. Testing this coil found 3.62K ohms, so it's good. Test the primary coil windings with a volt-ohm meter on the ohm setting. Connect to the leads that go to the point assembly and to the primary ground wire. You do not have to lift the ground wire to make this test. The reading should be between 2 ohms and 8 ohms between the primary coil winding points. You can test right at the coil at the solder points, or you can test at the end of the leads. The readings I received showed 4 ohms, so this coil is good. The next test is the condenser. Using a digital volt-ohm meter that has a capacitor testing setting, pick microfarad, test the lead of the condenser to the grounded case of the condenser. This condenser should be 0.2 microfarads plus or minus. Slightly higher readings up to 0.3 microfarad will work. If you don't have a volt-ohm meter with a capacitor setting, you can use an analog voltmeter. Select the highest ohm setting on the meter, touch one test lead to the case, then touch the other test lead to the wire and observe the analog sweep hand. If the hand jumps up a bit, then returns to 0, the condenser is not shorted and is functioning. This doesn't tell you the value of the condenser though. You can reverse the test leads and observe the jumping of the hand again. On this motor, the breaker point set was all oily, which would prevent this from working. So it must be removed, cleaned, and the point surfaces filed, then cleaned. This shows the various components in the magneto point set. The terminals for the condenser and primary winding, the cam on the crankshaft, the little push rod, the point set, and the cam oiler felt. Remove the screws holding the condenser lead and primary coil leads. Remove the hold-down screw at the base of the ignition point assembly, and this whole assembly will lift out. I removed the push rod prior to this photo, but how it operates is the rod moves in and out and pushes the bottom end of the breaker point and spring assembly, opening and closing the point set. When the points open, it collapses the field in the coil and sends the energy to the secondary winding and the spark plug, causing the spark. Remove the 2 terminal bar screws and carefully note how these pieces come apart. That way you can reassemble them correctly after each piece has been cleaned. Here, the push rod is still seen in the assembly. I left the condenser screw in to help keep the orientation of the terminal bar. Lay the parts out in sequence to reassure correct reassembly later. Note the insulating sleeve in the bracket through which the 2 screws pass. Clean and degrease each part using brake clean or carburetor cleaner. Examine the point that's attached to the bracket. Here you can see the center is charred and a little pitted. Using a point file, carefully grind the face of this stationary point until it's flat and shiny. Be sure to keep the file parallel to the bracket. File the point until the pitting burns are gone and the face of the point is shiny. Set aside for a few minutes. The breaker point can be seen here where the center is charred and slightly pitted too. The edge closest to my thumb is still a little shiny. This point needs dressing up with the point file. File carefully until the face of the breaker point is shiny across the whole face. The charred area in the center is very small but not quite gone. More filing is needed to remove it. The breaker point is now properly filed. Using a clean, lint-free cloth soaked with carb cleaner or brake clean, wipe the faces of both the brackets point and the breaker point. This removes file dust particles. Here you can see the black streak of file dust wiped from the face of the bracket's point face. The points must be clean for it to operate properly. Reassemble the breaker point bracket assembly. Be sure the insulating sleeves are still in place before inserting the screws. Do not tighten the screws on the terminal bar. Note the misalignment of the point set below. Carefully slide the breaker point and spring around until the point set is in a line and centered. Then tighten the 2 terminal bar screws securely. You can see in this photo this point set is in line. Reinsert the push rod with a drop of motor oil into the base bracket with the rounded tip toward the cam load. This breaker point set is ready to mount back on the magneto plate. Apply a few drops of motor oil to the oiler felt. Place the breaker point assembly into the slot on the magneto plate with the cam follower push rod towards the cam. Finger start the screw to hold the point assembly in place. It'll be tightened after setting the point gap. Turn the crankshaft clockwise until the woodruff key slots are aligned to the breaker point assembly as seen here. This puts the cam lobe at its highest point. Reattach the primary coil leads and the condenser lead to the terminal bar. Using a feeler gauge stacked to 30 thousandths, insert the gauge between the point set. Slide the base of the point set assembly toward or away from the cam so that the gauge slides in and out with a little resistance. Tighten the screw holding the assembly to the magneto plate. The point gap is now properly set. Insert the lower only woodruff key into the crankshaft. Reinsert the rotor assembly onto the crankshaft and align it with the woodruff key. Use a feeler gauge stacked to 10 thousandths of an inch to measure the gap between the armature and the rotor. Verify that there's 10 thousandths gap between the armature and the rotor, and as you can see it's been dragging, so this one needs to be readjusted. So I'm going to loosen this screw, insert the feeler gauge, tighten it down, and then do the same on this side, but I'll turn the rotor to align the magnet to this armature. Here you can see my stack of 6 thousandths and 4 thousandths in between the magnet and the armature. I'll tighten this screw, and I'll put it over here, do the same thing and tighten this screw, and then retighten them all. Again, I have my stack of 6 and 4 thousandths for a total of 10 thousandths, and you can see how this armature's been rubbing on the rotor, but I'm going to tighten this screw. Here you can see the 10 thousandths stack fits in, and it slides in. Thread the flywheel nut back on the crankshaft. I put a washer under here. I'm not putting the flywheel on because I want to watch these parts. And then I'm going to put a drill motor and turn it. Place the spring washer, then insert the woodruff key. Place the flywheel, aligning the woodruff key slot. And finger start. Using a torque wrench set to 25 foot-pounds and a strap wrench holding the flywheel, I'm going to torque this, but it takes 2 hands. Reinstall the rope plate, then the recoil plate, then the screws with their star washers. There's 3 of them. Using a strap wrench and this 1/4-inch drive ratchet, I'm going to tighten these securely. I'm now ready to reinstall the gas tank and the recoil starter, but I'm going to space these screw holes. I'm going to put some kind of a shim in here to set this on to determine how thick of a washer I need so that this doesn't drag. And this whole flywheel moves up and down a little bit. I don't know if you can see it. To make the spacers, I'm taking a little piece of inner tube and I've cut 6 strips. I'm going to glue them stacked one on top of the other. Then I'm going to temporarily super glue them to these raised pieces on the ratchet recoil unit. While these shim stacks are drying, I'm going to place the fuel tank over this, turn it over and put some screws in it to hold it together. I've aligned the top of the recoil unit to the top of the tank. You can see the holes are lined up. I'm going to just put in 1 screw here and 1 screw here. Screws are in. I'll close the door, turn this over, and confirm that my super glued pads are still in place. I've placed the tank in place and it looks like it's sitting flush there, but in the back there is a gap. And on the other side there's a gap here, and you cannot see this back one. This is the bracket that the fuel tank sits on, and it's bolted onto the side of the motor block. I'm going to loosen this bolt and see if I can gain 20 thousandths, 30 thousandths in height so that this center bracket on both sides is higher, and then I'll only need shims on these 2 locations. Loosen this nut. With the bolt loosened, look at how much height I gained here. So I'm going to hold this in the up position and tighten it. I'm repeating the same procedure on the other side. Now the fuel tank is sitting firmly on this bracket, and I'll need to add some shims to both rear brackets. I measured the thickness of the gap, and I found some aluminum stock that was just the right size, drilled the holes, and now I'm going to countersink the holes because I'm using a countersunk screw, which will give clearance. Here you can see I'm about to countersink these, but I can't do it with one hand. Here you can see the countersinking of this shim. Let me drop the screw in it, and it lays flush. I put just a dab of thread lock on this countersunk screw that's going to hold the shim in place so it doesn't work loose. There you can see the red thread lock. I put a 1024 screw in the main holes to hold the shim in place while I tighten this down. Take my alignment screw out. Now I put the alignment screw for the shim on the other side. Again with thread lock. Put the screw in.
These guys are flush. Then I'll remove this screw.
Putting the fuel tank back in position. Looking under here, it's sitting on this bracket. Back here we have the shim. You can just see the shim holding the fuel tank off of that cast-in bracket. And looking at the top, this thing looks pretty close to level. And if anything, the part that was dragging was the back part. So having the back just a little high doesn't seem to hurt anything. Reinstall the 4 screws holding the tank to the motor. This screw was a 1/4 20 and this screw is a 10/24. Looking at the underside, here's one of the 10/24 screws. This is the 1/4 20 on the other side. There's the first 2 I put in. But I'm working on a side project here to repair this fuel shutoff valve. So I'm going to take this all back off. Now that I have the shutoff valve in place, I went ahead and put the tank back on, and here's the 10/24 screw, and here's the 1/4 20 screws, and those are all tightened up. I've also put the spark plug back in. One thing missing here, the recoil starter, and I don't know if I can do this one-handed or not. I cannot. There are 4 screws. The short ones go here, the long ones go up here. The recoil starter screws are all in. I pulled this. It's turning the engine, but I'm listening for a scratching sound. I don't hear any noise, so that means the recoil is not hitting the flywheel. Here's the right side. Here's the left side. Reinstall the lower cover right and left sections by reinstalling the 4 screws located as shown on this picture. There are 2 on the left and 2 on the right. The magneto repairs are now complete. Thanks so much for watching.